Welcome to the breakout session presentation from Work Package 2 of Promotion on Converters and Topologies. My name is Christina Brantl and I'm a research associate with RWTH Aachen University. I had the honor to lead the work package during most of the time of the run of Promotion. Within this presentation, I'm going to give a brief overview of the objectives and the studies in Work Package 2 and then give an overview of the breakout session presentations that you can find in the other linked videos on the event page. So the objectives of Work Package 2 were a trade-off analysis of different topologies, taking into account the different possible designs of future HVDC grids, different sizes of them and different connection points. And then the interconnection of voltage source converters, so here typically modular multi-level converters is the state of the art of these converter type, and diode rectifier systems, so passive converters that need the controls of the offshore wind farm to function in the overall grid system. The next part was then the control concepts to ensure interoperability, and this is also closely linked to the diode rectifier, for example, so having a VSC link, diode rectifier link, or an AC link in combination, so then the control concepts of the wind farms and the converters would change depending on the connection point and depending on the different designs and topologies of the system. Moreover, also the interoperability between the wind farms and the converter was an important point within Work Package 2. Based on a broad investigation of those different topologies, converter types, and control interactions, the aim in the end was then to define recommendations on onshore and offshore power systems for existing grid codes, so to facilitate the development towards these meshed and multi-terminal systems in the future. So what are challenges in meshed HVDC grids? So right now we mostly have point-to-point links for offshore wind integration. But if we want to connect them to multi-terminal systems, there are several questions that we need to answer before we can start the investigations basically. So that is the normal operation and system design, for example. What is the DC voltage level? What is the DC side configuration? What is the operational strategy of these systems? These systems will probably be operated quite differently to the existing AC systems. And also the general point of interoperability. All these components have to work together, which is more challenging because of the controls involved in all of these components. Next part, when we interconnect those different systems, is the treatment of DC sides, faults, and contingencies. So what will be the reliability and availability criteria that we'll put on the DC system in the future? Also, what is the impact of faults on the overall system, and what are suitable fault clearing strategies to limit the consequences of faults? As already alluded to beforehand, because of the large-scale integration of offshore wind farms, the control of the wind farms themselves becomes more important. So on the one hand, using those controls facilitates, for example, the diode rectifier unit integration, but there will probably also be new requirements in the future because of fast power flow recovery or auxiliary services, and how can we use those control capabilities for example, AC and DC fault right through, or where are they needed actually? And the next part is when the systems become larger and larger, that we have to take into account the AC system dynamics. With those envisaged numbers of 200 to 400 gigawatts around Europe of offshore wind of offshore and onshore wind integration, the stability of the AC grid also has to be ensured in case of faults in the offshore grids. This is one part, so we have to respect the different frequency reserves, but we also, because the wind power plants become so increasingly integrated, there also needs to be a new definition of provision of auxiliary services between the AC and DC system, and also, for example, the AC fault right through of the overall system has to be ensured. So within Work Package 2, we tackled quite some aspects of this, and here I present you a brief overview of the study aspects and partners. So with regard to normal operation and system design, in general for Work Package 2, we design models and a corresponding system similar to existing offshore wind integration farms and build up the needed models to do all these investigations. And here I'll only focus on what were the actual investigations based on the setup models. So one part was for the optimal power flow with different objectives and their contingencies to see how can we operate those future large grids and what are the possible costs or contingencies and the impact on the overall system. And then of course the interoperability of DAUs, so how can we integrate diode rectifier units as a cost-efficient solution in the proposed and planned structures. Another part was DC side fault and contingency. So there has been a lot of work on fault clearing equipment, fault clearing strategies within promotion. I'd like to refer you to work package 4, 5, 6, and 10 to have more insights into, for example, DC circuit breakers design and testing, or the protection strategies. And within work package 2, we took the main component specifications and the main protection strategies and had a look at what is the impact on the DC system components and also on the connected system. So this is closely linked then to the control of the offshore wind farms. So the second point here is the requirements on the offshore wind farms for DC fault right through for different fault clearing strategies that we have a specialized presentation on within this breakout session. The other part was, of course, the DIU integration into mesh systems. Third part, with regard to the integration into the AC systems, with regard to AC system dynamics and stability, we had a closer look at frequency support, AC fault right through of the overall system, and then also of the impact of DC faults and the clearance on the AC power flow at the connected AC systems. So to study this broad range of aspects, this was only possible with a large crew of partners, and you can see them here on the right, covering consultancies, universities, manufacturers within the different fields of HVDC technology. And I'd like to thank all partners for their contribution to the work package. For this breakout presentation, we prepared 5 videos, and the first topic is the direct rectifier integration into HVDC systems. This video covers both DIU-connected wind power plants in parallel with point-to-point VSC HVDC links and HVAC export cables, but also the connection of a DIU-based wind power plant to radial and meshed HVDC systems, so covering both AC-connected DIU and DC-connected DIU. The second video is then on system planning and operation under contingencies. The first part contains the security-constrained optimal power flow for interconnected meshed AC and DC transmission systems with regard to, for example, the operational strategies of this integrated AC and DC system. The second part is then the application of RMS simulation of combined AC-DC grids, especially with regard to the planning of those systems. The third video covers frequency support, and there are 2 possible options that we investigated. On the one hand, the exchange of frequency containment reserve via HVDC grids connecting multiple synchronous zones, and also the frequency support for multiple offshore wind power plants connected through the HVDC grid. The fourth video is on interaction of HVDC systems and connected offshore wind farms under fault conditions. Within this presentation, there's first an explanation of the impact of different fault clearing strategies at the offshore connection point, and then we'll go deeper into the implications on the requirements towards the offshore wind farms and their controls. The last video presents recommendations towards HVDC grid codes, and this covers first an analysis of current status of HVDC grid codes, and then steps towards requirements at the DC point of connection. We invite you to have a look at all these different presentations available on the event page. And if you have any questions, please directly get in contact with the presenters, or you can also write me an email. And I'd also like to invite you to the live Q&A session, which will take place Friday, 4th September from 10 to 12, where the key results from all the technical work packages within promotion will be presented, and you can directly get in contact with me, the different presenters, and also the other work package members. So thank you very much for your attention, and I'm looking forward to hearing from you.